What you're hearing is a piano that's reacting to the movements of a player. When you move left or right, it plays a single note, and it plays harder or softer depending on how quickly you move the stick. When you move up or down, there's a randomized melody that also moves up or down to match. You can even move up multiple times and ascend up the piano scale. All the notes are in the pentatonic scale, so the generated melodies all kind of work, but I'm not gonna lie, it does kind of sound like a cat walking on a piano. This started as an experiment with ways that I can make a dynamic music system for my game Kitten Burst. I decided not to use this throughout the game, but I did include it in this introduction section where the main character, a cat named Happy, is first exploring a new area in cyberspace. I also used the piano to represent Happy throughout the soundtrack, so it's a good way to set that up as well. I wanted the whole game to feel synesthetic, with different systems running in the background, mutating the music in interesting ways. Here's a more practical example. When you're out here in cyberspace, the music is sparse, just a piano melody and some atmospheric horns. As you approach the hub ship, the Eternal September, more instruments join the mix, a double bass and some piano chords. This hub is where you travel to all the sites in the game. When you approach a hyperlink, you hear a hint of the music in that level. When you enter the bridge of the ship, the drums kick in, filling out the rest of the music. This is an example of a layered music system that you can find in a bunch of games. There's a few tracks all running in parallel, and depending on what's happening, you can fade in and out of these tracks. In this case, the music is responding to your location in the world. I have trigger volumes positioned throughout the level, and as a player enters or exits them, I send an event to my music system to enable or disable a track. I had a problem when I was first implementing this though. My tracks in the hub all kept going off sync. I think this was happening because I started all the music while the level was loading, and that led to each track starting at slightly different times. To solve this, I just added an intro. This single track plays when you load into the level, and when it ends, it triggers all the layered tracks to start at the exact same time. I love hub and spoke structured games. The hub level begins to feel like a home base between adventures. However, the hub music can become a bit stale since it's the most frequent music you'll hear throughout your playthrough. To try and prevent that, I included two different versions of each of the two main layers to the music. The far layer has different melodies, and the ship layer has different chord voicings. The game chooses these at random each time you visit the ship, meaning there's 4 different variations of the music you can hear each time you visit. I also have 3 different intro phrases that play each time you enter the level. While this is an example of location-based dynamic music, I also use state-based dynamic music. Kitten Burst isn't just a flying sim, it's also a racing game. Each of the levels in the game have their own layered music. When you're out exploring, you just hear this atmospheric layer. Then when you start a race, the drum and bass join in. When you start a race, I call races circuits in the game, like a computer circuit, but also a racing circuit, get it? When you enter a circuit, the music system plays an intro phrase into the race music. Each level's countdown is slightly different to match the BPM of the music. When you hit a checkpoint, I call them nodes in game. It's sci-fi fantasy, there's a lot of techno jargon. When you hit a node, the music system plays a percussion noise, also unique to each level to fit with the music. Whenever you enter a menu, the music slows down with the game speed, and a low-pass filter cuts out all the high frequencies. So how does this music system actually work? I'm not going to get into detail with the code itself here, but I'll show you how I designed it in case you want some ideas for your project or if you're just curious. I try to keep things object-oriented, meaning there's one piece of code that handles all the music in the game, and it communicates with all the other systems to figure out what it should do. This is my dynamic music system in the center, and it talks to my level system, which tells it where in the level the player is. When the player crosses a trigger box, the level system sends a message to the dynamic music system to switch which layers it should play. The dynamic music system doesn't need to know where the player is, it just trusts that the level system will tell it what to do. It also talks to my master circuit system, which talks to all the circuits in the level. When you start a circuit, the circuit sends a call to the master circuit, that sends a call to the music system to start the race music. Even the nodes themselves in a race are their own objects. When you hit a node, the node tells the circuit that it's been hit, who tells the master circuit that there's been a hit, which tells the music system to play a hit sound. This might seem convoluted to set up, but it means it's incredibly easy to add a new race to the game, hook up a few nodes, and it all just works. The player controller itself also talks to the dynamic music system for effects. For example, when the player crashes, there's this high pass filter that cuts out all the low frequencies. And when you boost, it adds a flanger effect. Let's walk through how this all is actually set up in the level. I've been working on this site that's going to be the final level for the game. It's a false utopia inspired by early social media platforms. It has this Frutiger Arrow aesthetic going on. Here's what the bass, atmospheric version of the soundtrack sounds like. I added an intro phrase that's kind of inspired by the startup jingles that play when you boot up an OS. Next, I added the circuits to the site. Here's what the race layer on its own sounds like. This is what it sounds like altogether. I also wanted to add some location-based music. There's trigger boxes for when you're above ground, when you're underground, and for the 3 buildings in the level: shop, work, and to live. Once those are all plugged in, we now have a music system that changes based on level, state, and player action. Here's what it sounds like in game. Listen to the music to see if you can hear the different layers fading in and out. In all these cases, the music reacts to the gameplay, but what if we flip it and have the gameplay react to the music? This is a boss fight in Kitten Burst. It's a 3D bullet hell that you have to outlast in order to drain the boss's ion energy, and it's all powered by music. That sounds cheesy, but it's true. Let me explain. This is a tick function in Unreal. It fires every single frame. If you wanted to say, spin this duck, you would hook up a rotation to the tick, and it would add some rotation every frame. Tying your gameplay to the frame rate is generally bad practice. It makes steady frame rate incredibly important, meaning you might lock everything to 30 FPS and make everything designed around 30 FPS, which makes the game extremely difficult to remaster. Instead, you should probably tie your gameplay events to the delta time. This is a gameplay variable that keeps track of exactly how much time has passed since each tick. If we multiply the rotation by this time, we now have a smooth, spinning duck. For the boss fights in Kitten Burst, I didn't use delta time, I used music time. I wanted my bosses to fire bullets and change sections in time with the music, kind of like a rhythm game. At first I was using delta time and assuming that it would stay synchronized with the music. However, any little stutter in the audio buffer caused a desync, which felt really bad. So instead of looking at how much real time had passed since the last tick, I instead look at how much music time had passed. In Unreal, that means looking at the playback percent of the boss music audio file that's currently playing. Now I just need to convert this playback percent into beats that I can fire bullets off of and sections so I can change what's happening throughout the song. Time for math. Here's the variables we have: playback percent, the duration of the song, and the BPM of the track. We multiply the playback percent with the duration to find the exact current time in seconds. We divide the BPM, beats per minute, by 60 to get the BPS, beats per second. Then I do 1 over that to invert it to SPB, seconds per beat. I have this variable current beat that keeps track of what beat we're on. Say we're at the start of a song. The current beat would be 0. If we add 1 to it and then multiply it by the song's SPB, we can find the time in seconds that beat 1 happens. So now every frame, we check the song's position. If it's greater or equal to the position of the next beat, we call a beat event and then increment the beat counter. Now it's going to check to see the position of beat 2 and so on and so on. In the boss fights, we can use the beat counter and beat events to do things like fire bullets, all in time with the music. I used to have some more logic that divided the beats into another variable that was using 4/4 measures, but then I made a boss fight song that was in 7/4 because I like to make things difficult for myself, so I just scrapped all that, just used beats and beat counters. I have this separate boss track object that marks the sections of a song. It's a spline that shows the path the boss will take through the level. In this path, I defined how many beats each section should have, and then use these sections to change the bullet patterns and trigger other events. Once you've reached the end of the spline, you've finished the song and owned the boss. This method of music-based boss fights also allows for a fun way of creating different difficulty options. If I night chord the track and speed up the BPM, the whole boss fight runs faster. I can also day chord the track and make an easier version of the boss, and it all just works. It's a ton more work to create dynamic music for a game. You have to make sure that all the layers sound good on their own, and you have to test and retest how it's implemented, but I think the results are worth it. Video games are an interactive medium, so it feels right to have the music feel interactive as well. Oh, I didn't even talk about the full acid-based synthesizer I added to the game. I have a separate short about that. Okay. One last example I wanted to show off. The story of Kit & Burst is a very core part of the project. I have dialogue scenes in the game, but I wanted them to feel cinematic. The dialogue system fires events to change the camera angles, but it too is connected to the dynamic music system. Here's an example. This is part of the intro to the game, a stasis array where Happy sleeps between cat races. The hacker Saber has broken into this bubble and asks Happy to help her hack a few sites, and in return she'll help Happy finally win a race. This scene has 5 parts, 3 cutscenes and 2 dialogue scenes. Each part has their own section of the song to play. When you're in the first dialogue section, this piano phrase loops. Then when you hit the cutscene, a new section starts. This last section is now playing a different looping system of the song. This allows the emotional beats of the story to be accompanied by changing emotions of music. Which sounds cheesy, but it's true. Okay, that's all I had. Thanks for watching. I'm gonna go finish making the game now.